Hello, welcome back. I hope you had a great spring break. Today we're just going to take a look at something called polar coordinates, which basically unites complex numbers with trigonometry. So let's start with polar coordinates, and then we'll get to the ones that actually involve complex numbers a little more directly. First, we're just going to do plotting polar points. And all that involves are a coordinate pair. Rather than being an x direction and a y direction, it's going to be a radius and an argument. And the argument just means the angle. So here we want 2, 3 pi over 2. So the 2 means it's on the second circle. 3 pi over 2 means that it is on the angle corresponding to 3 pi over 2. We're using radians here. Sometimes you use degrees here, but more often than not, you're going to be using radians when you're involving polar coordinates. So right here, we're on the second circle for radius 2. We're on the 3 pi over 2 kind of ray coming out of the axis. So let's go ahead and just try it. You're going to have 3 of those. And you're going to have 3 where you have to actually do that where you find the angle yourself. So let's try it. 1, 2, 3, 4. Negative pi over 3 is going to take us down to about here. Because it's pi over 3 less than the full circle. Because negative, meaning clockwise. I mean, this is pretty much explains itself, but if you have any questions, I can explain it more thoroughly, I suppose. Now, polar to rectangular form, what this says is given given a magnitude of 2 root 2 and an argument of 3 pi over 4, what are the actual x and y coordinates? So let's just imagine, I'll actually just go ahead and draw this out. Ignore the math research. We have, let's try this. 3 pi over 4, which is this direction. Let me draw that a little more clearly. And we have 2 radical 2, which take us 1, 2, 2 radical 2 to about here. Now really, if you're going to have a line of this length and you're going to have an angle like that, all you need to do is go back to the trig functions that got us there. So that's going to mean that the y value is going to correspond to, how to put, it will be, since this is the opposite and the 2 root 2 is the hypotenuse, we're going to say that, I guess we'll find the reference angle to get us started. So let's just go ahead and say we have, 2 radical 2 times sine of pi, oh, my mistake, 3 pi over 4. That is going to give us the y value. 2 root 2 cosine 3 pi over 4 is going to be the x value. And actually, this is going to be something you can generalize. You're going to get x equals r cosine theta for any radius r and angle theta, and y equals r sine theta for the same parameters. And if we actually plug that into a calculator, we're just going to get that x is -2 and y is 2. So let's just go ahead and plot that right here. -2, 2. Perfect. So you just, when you're going from polar to rectangular, you make the y value as r sine theta and the x value is r cosine theta. For the reasons that we went over, but I can explain it more detailedly in class. Rectangular to polar, this, you're going to need to use the Pythagorean theorem in order to get the magnitude. So you square them both, add them up, and then take the root. If we do that, we get +2 and +2, which add up to 4. Take a radical and you get regular 2. That's what happens when you square these guys and add them. But now, where is actually going to, how are we going to actually put this in reverse? Given r and theta, how do we find x and y? My mistake. Given x and y, how do we find r and theta? So we have found r by doing the square root of x squared plus y squared. Because Pythagorean theorem, it's the third side, it's the hypotenuse, because that's the one that connects the other two. So now we want to find theta. So if we do x over r is going to be cosine of theta. And that means if you take the inverse cosine of both sides, you'll get theta. And if you take the inverse sine of y over r, you get theta. So in our case, we have negative square root of 2, and we have 2 for our x and r, respectively. So let's just go ahead and calculate this. And before anything, we want to go ahead and make sure that we are putting our calculator in Radian mode. If we don't, we are basically going to screw ourselves over as much as if we were trying to take temperature in Celsius or measure a football field in centimeters, etc. You're just going to get the wrong number if you're looking for the wrong units. So what we're going to do is we're going to do, let's see, functions inverse sine of y, which was negative root 2, divided by r, which was 2. And we end up getting negative 0.7853. Let's go ahead and see if we can find something. Yeah, let's actually just go ahead and put this into another calculator that is more likely to give us something in terms of pi. I just pasted that. I don't know if it's going to like this. Oh. Yeah, it doesn't like that. So we're going to do arc sine of negative square 2 over 2. And that is our answer, but the exact result is negative pi over 4. Because right here, this is not a very clear answer. But this is a lot easier to put into a calculator. So negative pi over 4 is what we got here. Boom. Hold on a second. Let me go ahead and fix that. Oh, my mistake. It wants a positive value of r and a positive value of this. So negative pi over 4 would be correct, but it actually wants that to be between 0 and 2 pi. So let's just add 2 pi to this thing. So instead of negative 1 of them, we'll get 7 of them, because 2 pi minus 1 over 4 is just going to be 7 pi over 4. And I seem to be making some kind of mistake. So we always love it when that happens. I think the issue here is that this is actually a third quadrant angle. Just eyeballing this thing, I know it should give me something equal to 5 pi over 4, but I'm unsure why. Oh, it's because it's giving us a negative value, but the actual sine and cosine, like the inverse sine and cosine, are just going to give us a reference angle. So what we actually need to do is place that reference angle in the appropriate quadrant. And I just made the mistake of forgetting to do that. So we've got to make sure that we find the reference angle by taking the inverse sine and cosine. And that reference angle is pi over 4. However, we need to make sure it goes in the third quadrant because x and y are both negative. So let's go ahead and place that with an actual third quadrant angle like this, and then see if it likes our answer a little bit more. It does. So right here, we find the reference angle. I guess you could actually use an inverse tangent, and that might be a little bit more reasonable. So you can go ahead and I'll throw a third identity onto here. So this instead could just say inverse tangent of, now real quick, I think that needs to be y over x, but I'm going to double check that because it's been a minute since I've actually seen these. But note, be careful that this is actually going to give you the reference angle and not actually going to give you the exact value of theta. So you need to take the reference and find that. So let me make sure that it is a y over x kind of deal. Let's go to the next problem just to check. I'm going to show example. This one, next example, perfect. Yeah, they do a y over x here. So yeah. So basically, if you were going to eyeball it, you could just say it's 2 at, what would that even be? 3 pi over 4? But that's not a very clear way of looking at it. You would have to do the Pythagorean theorem to find the value of r. No, that's Benny Snell. That'd be this formula right here. And then you find the reference angle using any of these and then place it in the appropriate quadrant by looking at the positive and negative values of sine and cosine, meaning x and y. Moving on to the final section on this one is graphing polar curves. We want to select a curve and use the points to adjust. Let's take a look at this. We have not actually looked much into this, so this is going to be interesting. Let's go ahead and see the examples first. This is going to have a little bit more to it than some of the other ones. So if we actually were just going to graph the curve, we would put in some values and we get some weird stuff here. But I'm actually just going to remove this one from the assignment for now, and we'll see it later. So, y'all have a fantastic day. I will probably cover this stuff in a later lesson, just because a little bit at a time, y'all. Have a great one.